Okay, so to finish this session, I will cover a short tutorial on how to do a MCMC estimation with JAGS, and that is basically a short tutorial. So quick reminder, we want MCMCs to be adequate. So examples like that would be the trace plots in a caterpillar shape, autocorrelations descending and without differences in chains, shrink factors below 1.1, and density curves of each chain being very similar with holistic values, and also Monte Carlo standard error and effective sample sizes with reasonable values. Okay, as I said earlier, JAGS and STAN are the main players, so I will cover JAGS, but you can also are free to explore the options by STAN because I think they are really good. And remember that we have a reference by Solomon Kurz that is a free virtual book that covers all of what Krutschke textbook covers, but with scripts updated for BRMS. Okay, so there are several tutorials for JAGS, like for example this, to have a checklist of how to use JAGS using JASP. We also have some data, and this is our extra references, for example, by Van der Schoot page. So then we can have some materials and technical support to do a good job. Okay, so this tutorial will focus on how to build a JAGS model with JASP, just for illustrative purposes, because most of the times we will not use this module. It's just for you to see what is inside the machine that is operating in JAGS, and you can just alter it if you want it. For example, when we will deal with more complex methods, like for example Bayesian psychometrics or multivariate analysis, we will need to have more direct control on the MCMC, but then we will use, for example, R or M+ or something like that. Okay, so this module of JASP will use a JAGS, like from a direct command. So we need direct code for JAGS. In this case, we will use a nonlinear regression for a variable that is predicted by age and also by the squared values of age. We have these priors. The intercept of the regression is going to be a normal distribution for -35 with 0.05 standard deviation, two slopes for h and h squared with normal distributions of 0.8 and 0.2, and also a square distribution of 0 and 0.1, and also a tau parameter with a gamma distribution of 0.5 and 0.5. Okay, so this is the script that is available at our references to make a JAGS inferences in JASP. So as you can see here, we have a for loop for our sample size, where we have this regression equation and the differences between the slopes, and also we have the specification of the priors. Okay, as you can see here, intercept has a normal distribution with the set parameters, normal distributions here, and also gamma distributions. Okay. So and now I will shift for another video when I do this in JASP. So I will see you there. And this concludes the session 3 with the other video, the practical video.